Hello my dear students, this is your class SD and welcome to the ASD physics classes. Hope so doing really great. So students, in this video we are going to solve the question from the chapter. You can guess very well by seeing the question, moving charges and magnetism. Okay, and the concept behind this question is very important for the JEE mains exam also and the NEET exam also. Okay, so let's see this NEET 2016 question. Question is what? A square loop ABCD carrying a current I is placed near and coplanar with a long straight conductor XY carrying a current I. The net force on the loop will be how much here? Okay students, so here the kind of straight conductors we are dealing, they are the infinite length conductor here. Okay students, so for that we should know the basic of the force between the conductors when the current is flowing. Okay, because basic what will happen that now when the current will flow in both the conductors now, then what will happen? First conductor will be in the magnetic field of second conductor and second conductor will be in the magnetic field of first conductor. So because of the mutual mutual configuration and all, they will experience the force. So students, let's see the basic here. Very basic. Let's take here the first one I'm taking here, infinite length conductor both are. Okay, so let's take here current is the I1 and here the current is I2 because all these basics needed there here. Okay, and they are separated by distance, for example d. Okay, so what will happen that here force per unit length of the conductor is given by mu naught I1 I2 by 2 pi d. What is small f? Force per unit length. And which nature? As the current both in same direction, that means both the conductors will attract each other. What is there here? Here attraction will be there. Remember that, current in same direction, attraction. Next one please students, if I talk about this one here, let's take here current is I1 upward and here current is I2 downward. Anyhow, the force per unit length will be same if the distance between the conductor is d. But here what will be there? Here repulsion will be there. What will be there? A repulsion. This is R, repulsion. So here attraction and here repulsion. R-E-P-U-L-S-I-O-N, repulsion. Okay. So students, now let's understand the basic here. Now here what is there? See please. If you will draw here the current direction here. So what will happen there? See please. Here this is this current I. Here current I. Here current I and here current also I. Okay. So here we have to make the sections here. Anyhow sections are there only now. So if you talk about here, first let's see section AB and CD, because here you can see both this conductor and this conductor and this conductor is parallel. Okay, so students, if I talk about here section AB, so for AB section, can you guess very well? Current direction is same or the opposite direction. Here also upward, here also upward. That means what will be there? Attraction or the repulsion? Attraction will be there here. Okay, so let's take here. I have taken here. This is force AB. Force AB. So remember that here force AB, force on conductor AB, that means force per unit length into the length of the conductor. This is L, so this is also L here. Okay, that means which formula will form here? The formula will form here mu naught capital I small I by 2 pi. Distance between the conductors how much? Just guess please. L by 2 here. L by 2. Okay, and the length how much here? L. So students, just cancel out what other things can be cancelled here. You can see very well this L cancel, and what is cancel? This 2 and this 2 cancel. That means what we can get here? We can get here mu naught I by, can you see very well? It is coming here pi. Correct? Huh? Just check out please. Mu naught I by pi. Okay? Okay, good. Now students, after that we will go to the next one please. Now let's take, I have taken now section CD. Section CD. So force on section CD is how much here? Again force per unit length into the length here, this length L. Okay, so FCD will be how much here? Again you guess please. Mu naught I am using this formula by here how much here? 2 pi. And can you guess very well how much length is there, students? See please, this is L by 2, this is L, that means total length how much? L plus L by 2, how much? 3L by 2 here. So what this will become here? 3L by 2, and length of the conductor how much here? L. Now again cancel what other things can be cancelled here? Again this L cancel, this 2 cancel. Okay, that means what this will become here? If I write here, see here please, mu naught I by how much coming here? 3 pi. Direction of the force, can you guess very well direction of the force? Here you can see current upward. Here current is downward. That means attraction or repulsion. See please, opposite direction. What will be there? Repulsion will be there. And you can see very well, this distance is L by 2, but this distance is 3L by 2. So as this conductor is more distance, force will be there away, but it will be less. Here arrow length will be more, here arrow length will be less. So how much coming here? FCD here. Okay, this one we have got here. Now after that, if we talk about here the further conductors here, let's take BC and AD. Can you guess very well? For BC and AD, what will happen that here? We have to just use the little bit basics here. So you know very well, I will just draw the forces here. Actually, both the forces will cancel out here. Okay, so see here. Put your fingers along the current. Now this one, XY, along the current. Thumb, what to tell? This again I'm telling. This fingers along the current. Palm towards the observation point, then this thumb will indicate the direction of the magnetic field. So what will happen in this region? Magnetic field due to the straight conductor X will be in a which direction? Inside here. So this also inside, this is also inside here. Okay. Now what will happen that here? This conductor, which one? This conductor BC. It will experience force in which direction? This will experience force in which direction? Again I'm telling here. This one. Now your all your fingers along the current. This palm inside because magnetic field is inside, thumb is going which direction? Upward direction here. Okay, so here force will be upward here, F. Okay, upward here, force F. Similarly here you see here again all the fingers along the current. See here, all the fingers along the current, just all the fingers along the current, and my palm inside towards the magnetic field, thumb is going in which direction? Downward direction. Now you can see very well my hand actually. Okay, so now here what will happen that here? This force will be in which direction? Downward direction. Number of ways are there in moving charges and magnetism. Number of ways are there. You can find out the direction. Whatever is comfortable for you, you do it, no problem here. So what will happen that here? Force on BC and force on AD, both will, what will happen? Both will cancel out. Here also what will happen? If I talk about here FBC, so here we can tell here this force F, and here on AD, here also what is there? Force on F. But what will happen? Both will cancel out here. Here if I will write here vector form also, so this one we can tell here Fj cap, and here I can tell here F minus j cap. Just for the, I want to make you understand, both these forces will cancel out here. Now the net force experienced by this square loop will be how much here? One force is AB and one force is CD here, is it? And both these forces, this green color and this color, in which direction? Opposite direction. That means forces we have to what? We have to subtract the forces here. Okay. So students, let's see one by one here. We know very well this is mu naught II by pi, this is mu naught II by 3 pi here. Okay. So let me write here FAB minus FCD here. So net force here. Net force how much here students? See please. FAB minus FCD. What is FAB? I remember even mu naught II by pi, here mu naught II by 3 pi. Okay, just for you. We can check also mu naught II by pi and mu naught II by 3 pi here. Okay, so what will happen now here? Just take the what other things are common, and here 1 minus 1 by 3. That means what will come here? 1 minus 1 by 3, 2 by 3. That means mu naught II by pi into 2 by 3. And net force will be in which direction? In the direction of AB. Which direction is the AB? This side is the AB. So if you write even in a vector form here, let's say for example they ask in a vector form here. Okay, so what will become here? Mu naught II by pi 2 by 3. This side, that means minus I cap here. Okay, so let's check the option here. The correct option here, by seeing all of them, option A is the answer.